Today we will study about what is a shear wall. Shear wall is a vertical structural element used to resist the horizontal forces such as wind force, seismic force. These forces act parallel to the plane of the wall. Shear walls are generally used in high-rise buildings where effect of wind forces and seismic forces is more. The wall thickness can vary from 150 mm to 400 mm. What is a shear wall building? Reinforced concrete buildings often have vertical plate like reinforced concrete walls, which are also called shear walls, in addition to the slabs, beams and the columns. These walls generally start at foundation level and are continuous throughout the building height. Their thickness can be as low as 150 mm or as high as 400 mm in high-rise buildings. Shear walls are usually provided along both length and width of buildings. Shear walls are like vertically oriented wide beams that carry earthquake loads downwards to the foundation. So in the figure we can see a building indicating the shear wall. So how the shear walls are exactly placed? So these are actually located symmetrically to avoid ill effects of twisting. Symmetry can be along one or both the directions. This can be located at both exterior or the interior side. These are more effective when located along exterior. Let us now look at the functions of a shear wall. Shear walls must provide the necessary lateral strength to resist horizontal earthquake forces. When shear walls are strong enough, they will transfer these horizontal forces to the next element in the load path below them. These other components in the load path may be other shear walls, floors, foundation walls, slabs or footings. Shear walls also provide lateral stiffness to prevent the roof or floor above from excessive sideway. When shear walls are stiff enough, they will prevent floor and roof framing members from moving off their supports. Also, buildings that are sufficiently stiff will usually slip less non-structural damage. So in the given figure we can see what happens when lateral force acts from the left side and lateral force acts from the right side. When lateral force acts from the left side, the reaction is little different. The rotation becomes clockwise, and towards the downward the compression force acts and the tension force acts upwards. But when the lateral force acts from the right side, the rotation is anti-clockwise and the tension also acts on the upward side and the compression force acts towards the downward side. So we will see now how these shear walls actually provide the stiffness. The stiffness of the shear wall, just like its strength, depends on the combined stiffness of its three components: the lumber, the sheathing and the fasteners. The size and grade of end stud thickness and grade of sheathing and the sheathing fastener diameter determine how flexible it is. A wood shear wall will be, when present, hold down devices also contribute to the overall stiffness of the shear wall. If hold down devices stretch or slip, the top of the shear wall will move horizontally. This horizontal movement adds to the movement allowed by the luminer, sheathing and the fasteners. Any additional movement from the hold down will reduce the effective stiffness of the shear wall. So what are the different types of shear wall? Reinforced concrete shear wall, concrete block shear wall, steel shear wall, plywood shear wall, mid-ply shear wall. Reinforced concrete shear wall. Reinforced concrete shear walls are widely used shear walls for residential buildings. The reinforcement is provided in both horizontal and vertical directions. But at the end of each wall, bars are closely spaced and anchored. So, the end zones of reinforcement concrete shear wall is called as boundary elements or barbels. The wall thickness of RC shear wall is varied depending upon many factors like thermal insulation, requirements of building, age of building, number of floors of the building, and so on. It varies from 150 mm to 500 mm. In general, the provision of shear wall is continuous throughout the height of the building, but sometimes it is discontinued where there is a building entrance or parking space. Concrete block shear wall. Concrete block shear walls are constructed using hollow concrete blocks along with steel reinforcement bars. Reinforcement is generally used to maximize the effect of concrete block machinery against seismic loads. The reinforcement bars are arranged through spaces of concrete blocks in both vertical and horizontal directions. After placing bars in concrete block machinery, fresh concrete grout is poured into the hollow space and is allowed to set. This type of walls can take both gravity loads and lateral loads, so they can work like shear wall as well as load-bearing wall. Steel shear wall. Steel shear wall consists of a steel plate wall, boundary column, and horizontal floor beam. The action of steel shear wall is more like a plate girder. Steel plate wall acts as wave of plate girder. Boundary column acts as flanges, and horizontal beams acts as stiffness of plate girder. Plywood shear wall. Plywood shear walls are traditional type walls which are also called as timber shear walls. It consists of plywood sheets and studios. Plywood sheets transfer shear force while studs resist the tension or compression. Nowadays, plywood shear walls are redesigned using new technical advancements. Steel sheets, shear boards, etc. are used in place of plywood. MID-PLY shear wall. MID-PLY shear wall is an improved version of normal plywood shear wall. So in this case, the extra plywood sheet is arranged at the center of normal plywood wall, and series of pairs of studs are positioned on the both sides of the MID-PLY. Studs join the MID-PLY with outer plywood sheets. Here, studs are rotated to 90 degrees relative to those is plywood shear walls. The MID-PLY shear wall eliminates the problems caused in standard shear walls, and lateral load carrying capacity is higher for MID-PLY shear walls. The efficiency of shear walls. Efficiency of a shear wall is purely depends on its rigidity or its stiffness. A solid shear wall is more efficient than a shear wall with openings, but sometimes it is not possible to construct a shear wall without openings such as openings for doors and windows. In case of openings to improve the efficiency of the shear wall, we need to connect the piers of the shear walls by spandrels. Pier is nothing but the portion of shear wall between two openings, and spandrel is the portion of shear wall above the opening. The resulting wall appeared by interconnecting spandrels of piers of shear walls is known as coupled shear wall. Provision of openings in balanced pattern can also make the shear wall efficient. In flange shear walls, the walls will meet at right angles to each other. This type of shear walls are less efficient since they are affected by seismic forces in both principal directions of the building. Advantages of the shear walls: the tidier and more womanlike or workmanlike, speed in erecting as dismantling forms, good appearance, greater control of accuracy and workmanship, no protruded columns and beam for high rise, the straightness of the reinforced concrete wall, earthquake resistance, sound reducing, cost saving. It provides a potentially high ductile system with a good degree of redundancy which can follow freedom in architectural planning of internal spaces and external cladding. Their flexibility and associated long period may serve to detune the structure from the forcing motions on stiff soil or rock sites, significantly reduces lateral sway, and the construction is easy and implemented very easily. Disadvantages: these are basically poorly designed moment resisting frames which have been observed to fail catastrophically in earthquakes, mainly by formation of weak stories and failures around beam column joints. Beam column joints represent an area of high stress concentration which needs considerable skill to design successfully. It requires a good fixing skills and